Hello, everyone. Are you allowed to say good morning this late if it was a party the night before? Not sure. Okay. Thanks, everyone, for coming on the last session. I realized that you really just want to get this done to run off to the pool. But I promise I will keep you here until lunch, at least. This is the rerun of my session. We did it on Wednesday evening as well. We can also see that this might be the grand premiere, and that was the rehearsal. So today's topic is about how to give Lync and telephony to the users in the branches. So we will talk a lot about the architecture of the SPA and the SPSs. We'll talk about the alternatives to that and when to choose what. So I've done, we blended this. So I will start to talk about how it technically works, but I will also take the later part of the presentation to talk much about what we have learned during our project so far and how we have done this, because in many cases there is more than just Lync out there that we need to take care of. So my name is Martin. I'm from a company in Sweden called uClarity, and our focus is living in the land between traditional telecommunication and IT communication. And although we are not a pure Microsoft shop, my team, which is the technical team that works with technical deployments, we have a quite big focus on Lync at the moment, of course, because it's a huge momentum around there. But we also work with other vendors, and we work a lot with the ecosystem surrounding Lync, of course. So during the last years, we have done implementation with customers from between 5 up to 1,000 sites spread around the world, very different kind of industries. And what we have learned is that we need to be quite humble, because we need to find this balance between quality, quantity, and cost. Because if you are running a small deployment with a few branches, you probably have more time to spend on each site and go out and be nice and cute with the users. In the larger ones, where you are maybe pushing out a couple of branches a week, we might need to be a bit more aggressive, and sometimes you think that we are decreasing the quality there maybe, but it might be important. So we have done a lot of good things during these presentations, and we have also done a lot of things that we won't repeat. And I want to share that kind of knowledge with you during this session as well. So one thing that I've learned is that every site that we come to is unique, especially when we're talking about sites spread around the world and international sites. This is because the telephony culture in different regions and in different countries varies quite a lot. So it's important to try to find these local dialects and local ways to work, because it's quite easy to come from one place and just assume that everybody works exactly as you do. So that's something that we need to find. Each branch is probably also unique in the way which kind of user profiles you have there. Is it a sales office? Is it some kind of field engineer sitting there, or is it a mixture of these? So try to have a good understanding on that. There's also quite a lot of different offers on the market from local telephony vendors, from the carriers, and try to see that sometimes it's very easy to go and think that we should do it exactly the same way in all our branches. We should do it exactly the same way that we do here. And if the market doesn't give us these options, it might fail. There are also a lot of regulations and things like that we need to take into consider. Lync is also very different, because Lync might not compare one-to-one with the previous telephony solution. So in many cases, maybe when you're starting this project, you don't want to offend the users. You try to do it as similar as they have done everything before. and it might not be possible to do that. We should also see this as a great opportunity to actually change to something better. So in many cases, Lync can do fabulous things. So I don't think that we should be scared of implementing new things and new ways to work, but it's very important that we communicate with the people so they don't think that it will work exactly as before and things like that. Lync projects and voice projects might not be as, let's say, cut and pastable as many other projects. Many other IT projects start with a centralized thought, and everybody should work the same way. So, for example, email works exactly the way in all parts of the world. There might be some local dialects of how you work with resource mailboxes and distribution lists maybe. But I think that when it comes to telephony, we really need to realize that we might have to do some changes and some other things that might not apply exactly to what you do in your central site. So we're going to start talking a bit about our different options and how we can deploy telephony with Lync in the branches. And I come to think about two different approaches to this. One is what we call the centralized PSTN access. And basically, that's where we try to remove local equipment, remove local PSTN connections. Maybe the branch had a PRI before, a BRI, or analog lines or whatever, coming into something local. And we try to move that and instead take that PSTN access through the central site. And in some cases, it could be interesting to look at this because you will probably cut some costs. But in the same time, you might have new complexity because of reliability of networks and things like that. And one of the things that's very important to understand is that we need to find a carrier and work with a carrier that can give us numbers from each region, another country maybe, and take them to this central point. When it comes to SIP trunking, it might be easy to just inject the SIP trunk into the MPLS cloud, and it's not very tied by regions or country borders. When it comes to a PRI, for example, it might be a bit harder to take numbers from some other region and put them there. And this also varies a lot between different countries and different carriers. And it could be laws, it could be just the carrier don't want to help you with that. So you need to find a partner then that can help us. Also, in Europe, we have a couple of carriers that can give us like a SIP trunking service with numbers from different parts of the world. One of them are here, actually. And that can be very compelling. The problem with that might be that that carrier might not have the cheapest rates on calls. So if you do a lot of outbound calls, it might be a bit more expensive to go with that kind of carrier than to go with your local one. But if you have a low amount of calls from the branch, then it might be much cheaper to go this way. Even though the minute cost is higher, it might be cheaper than just bring in something local there. So the other one, the way around, is to do some kind of local breakout, of course, and everybody now starts to think about SPA and things like that. So let's just wait with how the technical solution works for a while. But the local PSTN breakout means that we still do some kind of PSTN delivery to that branch. It could be a SIP trunking service, it could be a PRI or a BRI, analog lines, whatever, something that we terminate into that site. And the good thing with this one is that you will probably be able to build some kind of survivability, don't rely as much on the network. We still rely on the network when it comes to Lync for everything else, conferencing and things like that. We'll always have some dependency on our own network, but we might have a local breakup that can give us that. That could also be easier from a legal perspective sometimes to work with these kind of solutions. So we need to find a path here. Should we do the centralized PSTN access or should we do the local PSTN access? And in most cases, it ends up that we need to blend it some way, because we just need to be humble and see that we're not able to do exactly the same way in the whole organization. And it's different things that will lead you to your decision. And we are going to talk a bit about that. But generally, the central PSTN access from an IT perspective and how we run our data centers is probably quite compelling, whereas the local PSTN access is always possible to produce in some way. So how do we do this? Let's start talking about the SPA or SPS, or the survival branch concept, and how that works. So in Lync 2010, Microsoft introduced a concept called the survival branch appliance and the survival branch server. And I think that most of you have heard of it, right? So what I'm going to explain during this session is how it works, and also give you a bit about the caveats, what doesn't work when we lose connectivity and things like that. So you know exactly what to expect. It might not be a huge amount of new things because the concept hasn't evolved so much since it was introduced. But basically, the SPS and SPA concept is based on placing minimal Lync code in the site. So we run two services from Lync, the front-end service and the mediation service. So the users that belong to this branch, they will register against this front-end service. So the users belong to this one. We don't have all the advanced functionalities such as conferencing, the user database, response groups, and things like that on the SPS or SPA. That kind of functionality still relies in the central site. So each SPA or SPS, I'm going to talk about the difference between those two as well, they are tied to one central site. So they are tied to a pool, which could be a standard edition server or an enterprise pool, but they are tied to one of them, and that's important to understand. So when the users sign in to their Lync implementation, they actually talk to the SPS or the SPA server wherever they are. So if they're sitting at home connecting through the edge, they still are home on this one. So from a SIP and signaling perspective, all traffic from these users will always go down to this one, unless something goes bad and the SPA goes down. But except for that, they're home here. Media paths might be different. You know, if you're sitting on the internet doing a Lync call, we'll try to do a local path for media, and that, of course, works the same way here. But the idea here is to be close to your implementation. So when you do your inbound calls and outbound calls, you will try to have a short media path, of course. So there are a lot of dependencies on the backend infrastructure. So if we lose connectivity to the data center, we will lose a lot of functionality. So response groups won't work. The conferencing stuff won't work either. So it's mainly basic inbound and outbound calls that's handled by this architecture. We also rely quite a lot on the bandwidth between the sites for conferencing, for example. So as soon as you are doing a conference, maybe with people in your same branch, or if you are doing a conference with people somewhere else in the organization, all the media parts go into the audio-video MCU will go back to the data center. So if you're using a lot of dialing conferencing, for example, it's important to see that when you're dialing in, the number might terminate in your local gateway and then travel to the pool. So latency here is of quite importance. So we're not able to do the survival branch concept if we have a huge distance between the central site and the branch, because we will rely so much on traffic going back and forth there. Another thing is that we also need to be quite sure that we can handle the load that this will put on for all of this conferencing. Many customers running into Lync and going to enterprise voice probably started with conferencing, so you might have a rough idea about how your network acts with this, but you still need to understand that there is a big dependency there. Okay, there's a couple of different ways to actually implement this and to do the survivable branch architecture in the site. And one of the concepts that was introduced that people probably spoke the most about is the survivable branch appliance, which is an appliance bought as a box from a vendor. We'll talk about the vendors soon. And the vendors will deliver that as a box with its own UI for how to go in and configure it. They have all the rules for how it should be updated, and they have the support responsibility and things like that. And basically, the SPA is based on a gateway component that takes the PSTN connection, do some magic with it to convert it to a SIP dialect that we can understand, passes it over to another component in the same box, which is a Windows server running the Lync front-end service and the mediation server, right? So if we are taking a call in here, basically, the call comes in to the gateway component, and if this is a analog line, the gateway will do its magic stuff, converting that into a SIP dialect that Lync understands and likes. These gateway components might be able to do PRIs, BRIs, analog lines. They might be able to do SIP. If you have a SIP trunk provider, for example, that does not speak a dialect of SIP that Lync appreciates. So that component can do all your stuff there. If you buy these boxes, there are some that are fixed models. So if you really know what you are going to do with it, you can buy a smaller one that's fixed and in many cases a bit cheaper. The larger ones are modular, so you can change the interfaces and move the modules around. What's important to understand is that the gateway component is where we terminate the call, and the gateway component can do a lot of good things for us. So even though you have, for example, a SIP trunk that works perfectly with Lync, you might have the need sometimes to break out certain of these DDIs and do something else with it. For example, if you have a fax, you might have some kind of analog device that shouldn't be sent into Lync. The gateways can maybe take that and send it somewhere else before it hits Lync. Faxes are a bit complex with Lync. I'm not sure if many of you guys have run into issues with faxes. Lync and faxes don't work together. It's just like that. So we need to take the fax calls away in some way. So the gateway, for example, could be a good way to pull it out and send it to an analog device, or maybe have actually analog ports on the same device handling that. So the call is then sent to the front-end service. The front-end service then send that call to the Lync user, and that's basically the idea of this. Everything that goes into some kind of conference, if it's going to a response group, that is sent back to the data center. Just talking about response group for a while, many of these branches probably need a main number that takes in the call for the office, do some IVR stuff and some kind of call distribution there. It might not be a huge issue from a latency perspective that's happening in the data center, because if you take that call, the SPA passes that to the data center. The prompts that are played here are just plain recordings. So they are played to you. You do your choices, and then you're connected. When you're then connected to a user in the branch, the media path can still be local. So it could be a working ID. But conferences will suffer if there is a huge latency between the SPA and the data center. So if we're talking about setting up a data center in Europe, for example, and having branch appliances in Far East or somewhere on the West Coast in US, the latency here might cause quite a lot of issues. So you might need to rethink your strategy and maybe place more local pools in these countries, unfortunately. So the vendors for these devices today, it's Audio Codes, Sonos, Ferrari Electronic is a company based in Germany. I don't think they're very, very common in US. And HP has also an appliance that fits into their server chassis. But I would say that probably Audio Codes and Sonos is the one that you maybe have seen the most. But there are more vendors, and both of them are down on the expo floor. So they do their appliance a bit differently. So you might need to go and have a discussion with them and see what fits you the best. And my recommendation is to try to go with one vendor, so you learn how to work with their tools, because everybody uses different terminology, they have different UIs to manage them, and it's good to train you on one of them, because if you're jumping back and forth with different appliances, it will be confusing in the end. We know that because we need to deal with all of them, of course. The architecture can be a bit differently in this as well, and just going back once onto this picture. Sometimes these gateway components are really standalone components, which means that they might work perfectly well even though the Windows component failed. So that gateway component can actually go and send an inbound call to some other mediation server if something goes bad. Sometimes it could be the other way around, of course. The gateway fails and the Windows components work. So if they are independent in the same box, it might be good sometimes. Some vendors, they more do a standard rack server, and they put in an extra card in it. And then, of course, you will have Windows running in the on the system, and you have dependencies between Windows, the application, and the card. So you need to find the way what you prefer. But there are differences. So just have a discussion with your vendor so you know that you're buying what you really like. Another alternative to doing the survivable branch appliances is a concept called the survivable branch server, which hasn't been talked too much about, which could be compelling sometimes. The survivable branch appliances was dimensioned for between 25 to 1,000 users in the beginning. There are a couple of different offerings. So I know that Audio Codes, for example, they have an appliance where they lower the specs a bit to make it a bit cheaper, and then it won't scale up to 1,000 users maybe, but it might fit perfectly if you're a very small branch. The survivable branch server is actually the same code that is running on the survivable branch appliance. Because when you're deploying these machines, you actually go into the topology builder, you define your new SPA, and what that is from a Lync perspective is just saying that this code will run on this machine. So you can set up another server, a standard Windows box in that office, and run the same code, and then use that one working with another gateway. So if you have a gateway from a previous implementation, or if you have a gateway or some kind of telephony equipment that speaks SIP in a way that Lync can do, that's actually another an interesting option as well. And that might scale a bit better, because if you put in more hardware and more memory and things like that than the SPAs typically have, you can maybe put up more users on that. But at the same time, if you put too many users in the branch, you get more traffic going to the data center from maybe a conferencing perspective. So the SPS is definitely a concept to think about as well. So the next topic is to talk a bit about what happens when things goes bad. Oh, sorry, I can take it first.
What's the type of cost differential between the SPA and SPS?
Okay, I repeat the question. The cost difference between SPS and SPA. The SPS is easy in that way that you just buy your server, so whatever server you're putting it on. You need a Windows Server license. The Lync code itself actually is not, it's like treated as additional software, so you don't like it. So it's not an appliance. No, sorry, I just need to be clear about that. The survivable branch server is something that you just deploy yourself. There is a little thing to know about that. From a support perspective, the SPS server is not supported to be virtualized. But the code that runs on that is the same code that runs on anything else within Lync. But from a support perspective, that's something to know. But you can deploy it on your own machine. And think about that, for example, you might have a gateway from the previous implementation that you want to reuse, or you have a requirement for more users and maybe that the branch appliance could produce. Then you can have another gateway with more capacity and have a server with more beef in it. So it's just a server that you deploy yourself.
Okay. So the SPS doesn't contain...
No, you can't go to the store and buy an SPS. So you buy an SPA in that case. So the SPAs are what's sold as an appliance and what's sold as a box with Lync on. Okay, sorry about that. Exactly. The SPS server only runs the mediation service and the front-end service. So all conferencing and everything else. So it's the same code that's run on the SPA. It's just that instead of deploying it on that SPA, it's deployed on your own server. So site resiliency then. What happens when things goes bad? So this is the branch appliance on a good day. When the user comes into the office, let's start with a desktop phone. When a Lync Phone Edition, for example, boots up, it will discover its SIP registrar by using DHCP first. So the client will send a DHCP request asking for an IP address, of course, and will also ask for its SIP registrar. So in that branch, you need to have a DHCP server that both gives you IP addresses, of course, even though if the WAN is down. So it's important to have some IP addresses, even if things go bad. So a local DHCP server is needed. If that DHCP server is actually the one that gives out the scope options to inform the phones and the clients about where the registrar are, that's something we can debate. You can either do it on a Windows DHCP server or any other DHCP server. But if you have a DHCP server that isn't able to give out, or in an easy way at least, give out the information about SPA, in this case the SIP registrar, and the web service that we'll talk about a bit sooner, then the front-end service on the SPA or SPS can actually act as a DHCP server itself. That DHCP server will only give out the scope options to tell the client where to connect. It will never go out and give you out the IP addresses and do something other. That DHCP response that you get should point you to the local SPA or SPS. So the phone here finds its way to its SIP registrar by going to DHCP. That's the primary, what you do, the first attempt, you try to do that. If that fails, it will go to DNS. Whereas Lync clients running on a PC, for example, they discover where to go through DNS. So they will ask either a service record or go for the Lync internal URL. So we will discover where to connect through DNS. Then the clients try to sign in, and depending on where the DNS entry or the DHCP entry was pointing them, they go to that local SPA, or in some cases it might actually be pointed back to the site, for example, to a director or to the pool. But whoever answers that call will send the user back to the SPA, because that's where he is homed. So the user should register against the client or the SPA. I have a couple of errors that I might show added. We connect here at the first time. We try to authenticate. If this is the first time we are authenticating, we will be taught to talk to the backend pool, back in the data center, to the certificate provisioner, and to client certificates in this case are sent back to the site. So both the client and the SIP phone will get a client certificate. And this is a very important thing. These certificates are used for all subsequent authentications. So the idea with the survivor branch architecture is that we shouldn't have to put in local domain controllers there. And Lync doesn't use the read-only domain controllers. So if we lose the connectivity to the central site, we should still be able to authenticate against this local equipment. And that's what we're doing with certificate-based authentication here. So this is done the first time. These certificates are then valid for typically 6 months. It's something that you can do shorter and longer, but typically for 6 months. So as long as the certificate is valid, you should be able to register to your pool here. It's important to understand that these certificates are provisioned automatically during the first time. So if we have an outage, for example, and a new user is connecting for the first time, it might not work. So it's important to understand that new clients need to register on a good day. But on the same time, the idea is not to have the SPA down for months or anything like that, and you need to reconsider how you do things anyway. So during a bad day when the van is down and all other services are down, you might not be able to deploy a new user either. So it's important to understand that. There's other way you can connect into the data center and do it there maybe. So let's see what happens when things goes bad then. So what different kind of things can go bad? Van failure, for example. In some way we lose connectivity to the data center. It could be our local van goes down, the pool goes down or something like that. But anyway, we are isolated by ourselves. Clients are mainly speaking to their SPA or SPS server in the site. And when the SPA or SPS server realizes that the backend database is gone, our conferencing functionality is gone, everything like that, he will tell the client that now we are on our own and we go into something called resiliency mode. Resiliency mode means that we have limited functionality. So typically, we will see it on the client. On a Windows client, for example, a red banner is shown and saying that we have limited functionality due to network outage. The SIP phone will also display it promptly for you. So during this period, we still are able to do outbound calls, of course, because we have the SIP registrar, we have the mediation server, we have the gateway, so we can send calls out. We can take calls coming in, at least if we are getting calls on our personal DDIs, so it's sent to me. But if a call is sent to the response group service, for example, or the dialing conferencing service, then we're smoked. Okay? So emergency calls and things like that, everything like that should, of course, work, but we have limited functionality. So it's important to understand that if we are deploying this model, the name survival of branch appliance sometimes might sound like we solve everything with it, but it's important to know the limitations of it. So this is something that will be. Another thing that can happen, of course, is that the SPA or SPS fails. So what happens then? Then there's actually a better scenario, because if the local equipment goes down, clients will actually go and register with their pool instead in the central site. So during the logon, we get information about our primary registrar, but we also get information about something called the backup registrar. So if we realize that our SPA is not responding anymore, we will go back and do something like registering with the backend server, our backup registrar, which in this case is our pool. So the users will register there as well instead. And the good thing with this is that our user base, our user database with our buddy list and all our scheduled meetings, everything where the conferencing is happening, is on that pool. So from an end user perspective, he doesn't see anything now. He sees that he's get disconnected and he gets connected again, and there's a polling value here. If we realize that we don't have contact, it might take up to like 2 minutes or something before we are re-registering. And then during this period, when we are registering against our backup registrar, we will check back and see if our SPA or SPS is coming up again. We'll check that every 240 seconds. That's a value that you can change, but it's probably a quite good value. So with this, you're actually able to utilize all the functionality that are living in the pool. So if your voice routing are set up, so you can use the central site's PSTN access to make outbound call as a secondary option, you will be able to place calls outbound. Of course, you might need to go in and see what happens, for example, if the branch is based in Germany and the central site is based in London. We have different carriers. You might need to go in and make sure that when we are doing outbound calls from this branch, make sure that our DDI that's written on me really are allowed to be sent out through that carrier, or maybe go in and make a voice route that makes sure that we write the main number for the central site or something else that belongs to the central site when it goes out, because otherwise the calls might stop there. But from a routing perspective, we can send it out there. Just verify that it works, that it really works the way you thought it should. So you probably need to play with this before you put everything in production. So inbound calls then, of course, they keep knocking on your door while your gateway is down. So depending on the carrier and how long we think this outage will be, we might need to do something about that. Some carriers are able to do rerouting now when nothing responds. So we have done a solution where we actually have a SIP trunk in one country, and we have talked to the carriers. So if our equipment doesn't respond, it will be sent through another SIP trunk to the data center instead. In this case, it was the same carrier, so it's quite easy for us to do that. But that means that calls are sent into the central site and everything works as normal. It might take a while for them to realize that change, so some of the first call might fail. But when that works, the users won't see any difference at all. So in our case, there's quite a lot of distance between the central site and the branch. So in that case, there is maybe a latency in the calls that user can experience during this time, but it's probably much, much better than not having anything at all. So they're quite happy with that solution. It might not be able to solve that in any case, but at the same time, we should try to build our solution so that we are able to replace equipment and make that poor guy come up soon again. Depending on how the SPA is built, remember I talked a bit about the gateway being independent from the Windows component. We might end up with partial SPA failure as well. So let's say that something goes bad during Windows patching or something goes bad. So just the Windows component in this case goes down, which would probably never happen, but could, right? If the gateway is still alive and operational, we can set up some of these gateways to actually have a secondary path there as well. So when a call comes in, that gateway can send it to our local mediation server. If that doesn't work, we can send it to a mediation server in the data center. So in this case, for example, the users will be registered against the central site as a part of the backup registrar thing. And the media path might change a bit. So depending if we use media bypass or not, we will send the calls into the data center or maybe handle it locally. But in this case, the user will not experience very much at all. Maybe latency depending on media paths. But functionality will be maintained during this outage, which is pretty cool. The other solution that we talked a bit about before, the central site concept, instead of putting out local equipment, what happens if we lose connectivity to the data center in this case? Let's say that we have a WAN outage, our central site works just fine. If we're able to move the users to another connection, maybe send them home, put in some kind of other internet access, LTE, whatever, then we actually have the possibility to let the user go through the edge infrastructure and register there instead. And in this case, they will probably have good functionality. You just need to consider bandwidth, of course. Are they sitting on the internet far away? Did they not go home? They went to Starbucks instead. Does the network work well from there? But that gives us some functionality as well. And the important thing to understand here is that with this concept, we actually don't lose any of the functionality, because all the things like dialing, conferencing, response groups, and everything like that, it's still maintained within the central site. So we will have full functionality. There might be things, if you have some kind of contact center application that are built relying on Lync. Some of these applications have clients that help them sign into queues and things like that. If these are not working over the edge and maybe require VPNs and things like that, you need to make sure that your instructions are complete as well. But just basic calls, making everything basic calls from a pure Lync user, just using the Lync client, that will work fine moving them to the internet. And I'm not sure how many of you guys are using the Lync Phone edition. Anyone? Yeah. One of the things that I love about that phone is that I can actually bring it home. I can take it from the office. If it's just been connected once, I can bring it home and connect it to my internet connection at home. It needs to be cable though, but it will work perfectly from there. So if we have a longer outage, we can actually move the phones quite easily, which is pretty cool that they can actually connect over the edge. Okay. One last thing to explain before we leave the SPAs for a while. Are you aware about the concept called pool pairing? Have you heard of pool pairing? Pool pairing is a function within Lync where two enterprise pools or two standard edition servers, for example, can also act as backup registrars for each other. So we pair these pools together, which is a quite cool function, because if one pool fails or one standard edition server fails, users will automatically be redirected to the other pool and register there. First, they go into this resiliency mode, as I spoke about before, but after some manual intervention, we can actually activate that secondary backup pool with everything else. So conferences will become live again, and we are able to actually migrate response groups. There's some manual tasks for that as well. But that's a quite cool function. And a lot of people that went into Lync 2010 build maybe they started with an enterprise pool, but they didn't have a lot of users. When looking into 2013, they actually thought about doing 2 standard edition servers and do pool pairing instead. It doesn't give you high availability, but it gives you a very good disaster recovery plan or disaster recovery option instead. One thing to know about the SPA and SPSs is that they don't like pool pairing too much, because the SPAs and SPSs, they are paired with a pool. And if we have a pool failure of our backup pool, they don't know the secondary backup. There's no backup for the backup, so to say. So, pardon? Yeah. You need to pair the SPA. Yeah. And the thing is that you can use pool pairing anyway, but you just need to understand that if that fails, you might have to go to that SPA and kind of reconfigure that one. You might need to move the users and do some kind of tricks, which could be quite a lot of steps. And if you have a lot of SPAs, it might not just be worth it. And I don't say that you shouldn't use them in combination. You should just know the limitation, so you're not surprised when you do anything like that. That's a main reason for this. So when the SBA and SBSS doesn't fit, then there are scenarios that when this might not be the perfect option. And one thing that I come to think about is geographical distance. You know, the speed of light is one of the limiting things for centralized Lync deployments. If we have a pool in Europe, for example, and we have a lot of people sitting in Australia, we probably have quite a lot of latency on that link. Just the speed of light going halfway around the globe is 70 milliseconds. Add some equipment on that, and you will get quite a lot of latency. If you have a pool sitting in Europe, users in Australia, and they are doing conferences with each other, these conferences need to go up and turn on the audio-video MCU and back again. So just because we have a very small branch that we want to give telephony, the SPAs might not be the perfect situation there. So what we probably want to do, if we're going serious with Lync, is to have pools in different parts of the world. So how can we do that? So take this, for example. Instead of doing a branch site, we might actually go in and deploy a full pool there. And if we are in a very small branch, or not a very small branch, but a smaller branch, we might put in a standard edition server or something like that. Important to know then is that the pool pairing concept that we saw with the SPA and SPSs, they are built for one pool with several SPA and SPSs. If we do the pools with an enterprise pool and a standard edition pool, if we do pool pairing things there, then they are pool pairing together, and there is just a one-to-one relationship. So that probably don't fit very well. Let's say that this is a central site in Europe with 1,000 users. We have a branch in Australia with 100 users. Setting up a standard edition server there might give them very good functionality when everything is under perfect conditions, because they have a local audio-video MCU for meetings, they have local access to response groups and all that kind of functionality. But if we try to do some kind of pool pairing here, then we need to be aware that if it fails in Europe, you will have 1,000 new users in this branch. You probably don't like that. So this is not what it was built for, but in some cases we need to do that. So we can maybe pair two standard edition servers between two branches in that part of the world, but it gets a bit complex, and you just need to understand that you do the right thing there. So.
Microsoft recommend that if you've got an enterprise edition, you put pair with an enterprise edition.
Absolutely, yeah.
But it works between us. Does it work with
Absolutely. You can pool everything because they don't realize that they're differently, but it's important to understand that if you're doing the pool pairing thing, you need to build them and scale them so they are prepared to take the load of the other one. And of course, a standard edition server and an enterprise pool, in most cases, they probably have a different user base, and that won't work. But I mean, technically, if you have 100 users on a standard edition server and 100 users on the enterprise pool, technically probably take the load of it, but I wouldn't recommend it. So. But I just want to give you tell you about the options, that if you need these things locally, you might do this. And you might think about other ways of doing resiliency for that branch. You maybe have possibilities to do some kind of co-location and set up another SPA. You need to build it within that site, it's more to say. Okay. I'm going into another part of this presentation now where we are leaving some of this technical stuff and talking a bit more about how we do these projects and our experience from that. So first of all, when we start these projects, early in the preparations, we go out and do what we call a site survey, or at least we ask the client to let us do a site survey. And that site survey is to give a rough estimate about how the organization works. So if they have, let's just say, 20, 30, 50 sites or something, we send out a survey to people in all these sites asking about what kind of user base do they have, how many users are they, what kind of users are they? Are they field engineers never being in the office? That would probably have an effect on our design. Are they salespeople sitting, making loads of phone calls, support maybe? So you get an understanding of what kind of users are out there. We want to find out about the current solution. What do they do today? Do they have their own PBX? Are they doing everything with cell phones? Are they a part of someone else's PBX? Quite common in our case. We have came to customers where our customer has bought a part of another company, and we need to move them out and just to see what they're sitting in at the moment, what kind of solution is that. What kind of carriers are they working with, so that we can go out and ask things now when the client doesn't know everything themselves. And also ask about contracts. If we have a list of 100 sites, where do we have to start? One contract is terminated in 2 months. Okay, that might be a hurry. Another one, so we can build the prioritization, and we know that we don't run into any contract discussion that we have to extend the contract, which might be very expensive. So when we've done that, we can build a rough estimate. One important thing about this service is that you shouldn't go in too much detail in the first steps. But because many of these surveys, when they are sent out to like 20 or 40 sites or 100 sites, the ones responding to them might be different kind of people. Some sites it might be some CFO guy, and might be a IT person. It could be whoever. If we ask too complex things now, we just realize that we do not get any responses. So don't ask too much, because they won't respond to you, and you need to hunt them. So when we've done that, we get a rough understanding about how the environment looks. We do a workshop with local IT, looking at network and how that works. We try to build a blueprint, and this is a blueprint that we try to use throughout the project. And the blueprint can say that, okay, for this kind of site, we prefer that kind of solution. For this kind of site, which is a bit bigger, we might prefer this, and also take in all the advantages of that. So it's good, so we don't end up with thousands of different solutions in each site. So it's important to have something. We always need to be pragmatic about that, and we need to change the way somewhere. Then after that, when we get a rough idea about how it looks, our homework starts. So everything about collecting information of the particular site that we are starting with starts now. And if you cheat here, it will bite you quite soon. So be sure to really ask the questions, and I'll come back to that. But if you ask a question and there's any doubt in it, ask it again and again and again and again. Because if you get different answers every time you ask them, then nobody knows how it really works. So you need to see that. And one problem that we've seen in many cases is that telephony was bought 10 years ago. It's a box sitting on the wall in a wardrobe or something. Nobody really knows how it works, but it probably works great by now. Nothing works as good as when you're going to replace it. But it's important to go in and see what kind of functionality is in there. And it's hard to ask people, what happens if I call that number? Oh, it's sent to the salespeople. But it might also have some kind of backup route that people don't know. So do your homework really well. So we generally start with some kind of workshop. During that workshop, we try to get answers on everything, like what kind of requirements do they have? What's their current solution? Try to be more detailed. What do they really know? What kind of PSTN connectivity do they have today? What capacity? Are they doing a PRI, BRIs? And in case of BRIs, how many are they? Or are the capacity enough? I mean, if you're doing a 30 channels PRI into a site today, and you implement Lync, and people start using simultaneous ringing and functionality that they never had before, every call that comes in and are answered on a cell phone will allocate more channels. So is that capacity we have enough? That's important, because if we buy a gateway with a fixed number of ports, and they 1 month later need something else, we need to replace that one, and that will be expensive, most probably. We also start doing migration planning, just checking out what time frame what we have, how many users are there. So we'll come back to that a bit. After that, we need to try to find out how to build this solution. So one thing is number planning. We need to find what kind of number series do they have, who owns that number series. Especially if you're buying a company that was part of something else, you probably have a number series with a blend. Who owns that one? Can you really take some numbers and port them independently? And then you need to understand how people do their how they dial numbers, we call dialing habits. So need to do the normalization rules and all the dial plans and things like that. And if you're from another country, it might be a bit hard to understand exactly how numbers works in each region. I tend to use Wikipedia just to get an understanding about how the number plan works and read from there. And it's quite a good source. For example, going to Germany, Germany has a situation where you can have a variable length in the number series. So it could be like a 7-digit number going to the switchboard, whereas users have a 10-digit number and things like that. And that creates a huge range of numbers. And some equipment might have it a bit hard to really deal with that. So we need to understand how things are worked. What's the service number in each country? Some countries have like a 4-digit number for UPS or something, and they have different numbers for like 911, 112 is probably quite easy, but then you have special numbers for other ones. You need to understand that. One tool that I find very helpful is an MVP fellow called Ken. He built this dialing rule optimizer. I'm not sure if you've seen that one, but that tool can actually help you to build a basic dial plan, taking care of different kind of numbers and how you deal that. So it generates a PowerShell script actually that you can use to import this one. It is important. You always need to check the results to see that you are happy with it, because there are local variants, and the naming of the normalization rule might not fit exactly of how you thought it should be used in your organization. So one thing that I think is important when doing dial plans and things like that is have a good naming standard, so you can reuse some normalization rules and you can see what dial plans are used for. So this is a very helpful tool. Next thing is that we need to go in and identify all the regional stuff happening in the country. And how many of you are here from US? Okay, and how many are from Sweden? Oh, sorry, I just happened to know that there's a lot of Swedes here. Telephony works in a lot of different ways in different parts of the world. So I know that in US you have you really love your voicemail, right? Okay, but you tend to use voicemail quite a lot. So in many cases, if we are having some kind of automatic call distribution, nobody answers, it might end up in voicemail, right? And in many other parts of the world, that's a big no-no. It should always be sent to someone else who answers that, and I used to call that a manual voicemail because it's the same thing. Still disturbs me. So many parts of Europe, people don't even like voicemail, and the companies say, we don't want to use voicemail. But Lync loves voicemail. And because we don't have a busy tone, voicemail is quite important, because if we don't answer the call, if we're busy in the call and someone tries to call us and you never end up in something else, you're quite ignorant, right? So voicemail might be very important for Lync, so you need to explain that. So I think we should use voicemail, but it's important to know how to use it. In many parts of Europe, and especially in the Nordic countries, we don't use desktop phones anymore. So in many parts of Southern Europe or US, I know that there's a lot of desktop phones in offices, whereas in the Scandinavia, for example, where I'm from, we generally use cell phones instead. So most company PBXs use a function called mobile extension, which actually means that when a call comes into your landline number, it's actually sent out to your cell phone. When you do a call from your cell phone, that call is actually taken back to the PBX, sent out again, which means that you always show your landline number. We can also have a check and see the line status, so the attendant, for example, can see if the user is busy in a cell phone call. So we have quite a lot of functionality around that. If we go out and say that, hey, here's Lync, here's your new desktop phone, and give me back your iPhone, people won't be very happy either. So we need to see how this local dialects affects to meet the user's requirement. On the same way, I'm also totally aware of we cannot go out and do special solutions for everyone. So I don't say that this mobile extension thing is fantastic. There's loads of different issues with that. It's quite expensive as well. But we need to understand what kind of it is. So it basically comes down to how many users there are, how loud they are if they're unhappy, and we need to try to find. So local dialects of how it works. There's also totally different markets. So different markets have different offerings from the carriers. So in some countries, PRI is not delivered anymore. It's just SIP trunks. In other countries, there are no SIP trunks available at all. So we need to find a way to work with this and don't be too stubborn that we want to do it exactly the same way in all regions, because we might end up with a solution that doesn't work for us. And there's also quite a lot of different things when it comes to laws and regulations. So what we are allowed to do. So, for example, if you're working with countries like India or Pakistan, they have a lot of rules against toll pass, which means that you're not allowed to break in or break out calls however you want to. So in that case, you might have to go in and look at the way you do kind of least cost routing things and all this kind of stuff. So you need to be aware of that if you don't want to get stopped at the border when going home from the site deployments and sit in a jail in Pakistan. Doesn't sound very nice. So you need to know that. And there are other things as well. How do you deal with emergency numbers? Some states in US, for example, have rules of how you don't just have to send it might not be enough to just send the street address. You might go into much more detail. In Europe, laws has been tightening up during the last couple of months and years. So we also need to send more information than just 112 when making an emergency call to make sure that we end up at the correct emergency center. In some countries, that is a law. You need to do this. In some countries, it might be just a recommendation, and you need to see that. So when you're doing, for example, the central SIP trunking thing, how is your carrier able to take care of a 112 call to another country, another city? So are you able to do a call to 112 or 911 from a site in Germany through a SIP trunk coming in Sweden, for example, and present that in a good way so you don't end up in Stockholm with somebody who doesn't understand how it looks in Frankfurt? So these things can also have an effect on the design. So you need to see that, but on the same way, it's also very easy to go out and speak to someone at the local branch and they say that, okay, you need to do like this and you need to do that. And in many cases, these are assumptions as well. So check the facts so you don't end up with a very expensive solution. So ask several times. So except for what we are replacing, the old PBX, and putting in Lync, there's probably quite a lot of other things out there that we need to take care of as well. And one of the things that we have run into many issues with is faxes. Especially if we have a series of number with, let's say, 100 numbers, and the fax numbers is number 34 in that series. If we are going for a solution where we're not using any kind of gateway that can give us possibility to break that out, it could be a bit hard to go to the carrier and say, can you take this number 34, port that to an analog line coming into that building? They will say it's not possible. It's probably possible, but it's probably not very practical for them, so they tend to not allow you to do that. So that could actually force you from going from a centralized SIP trunking solution to send to another country, instead doing the SPA and the local gateway just because that fax. So a fax can be extremely expensive. And the problem is that you're not able to send the fax within Lync and have it sent back to like an analog gateway because the media doesn't flow through Lync. So it could be a bit complex. So you need to find a solution for that. So faxes must die, in my opinion, but it's a couple of years left, I know that. Analog phones, it's much easier. DECT and Wi-Fi handsets, so analog phones can in most cases be handled by a small analog gateway. Quite cheap, quite easy to handle. DECT and Wi-Fi handset can in some cases be handled with analog devices as well. Some DECT and Wi-Fi handsets might be SIP-based. They may speak a SIP dialect that Lync doesn't understand, and in that case, you might need to handle that as well. I have a product that we've been working with is called SIP phone support from Audio Codes. It's a gateway component that acts as a back-to-back user agent for SIP. So the SIP phone registered against the SPS server, and the SPS then registers into Lync, and it works as a trusted application, controlling your presence and things like that. And that is a very good solution in some cases. It might be expensive to have a huge amount of phones, but it can solve that. We've been using that successfully. There are also vendors like SpectraLink that has both DECT and Wi-Fi handsets that register directly to Lync. So if it's a small amount of devices, it might be better to just replace them. Door phones, we have done so many workshops that we asked about the door phones, and they said that there is no door phone connected to the rest of the system, but when we are about to leave, nobody comes into the building. So door phones, there's always door phone. That's something we're joking about. Door phones are generally analog phones. In some cases, they are handled by the building, and they're just redirected to a number. But still, you need to check if there is one. And if you're in doubt, just go out and dial, press the button, and see what happens. So you need to check it. Alarm systems is the same thing. Alarm systems don't go off and don't call unless something goes bad. So if that's connected to it, we need to make sure that we really try that. And in many cases, it's just an analog line connecting to a gateway, but we need to prepare. So if you come to the site, it's very good to have to make sure that you have the right amount of ports for that. And if you talk to the CFO, I'm pretty sure that he's not able to give you the exact answer on how many analog devices there really is. So you need to check on that. I actually always bring a small analog gateway in my suitcase when I travel. Not when I'm going here maybe, but when I'm going on a deployment project, I always bring this gateway. And sometimes I'm just prepared to leave it because I rather fix that before leaving than having like a potential rollback or any other crazy thing just because the door phone didn't work. So it might be a good thing. You can sell it expensive to the customer if you didn't answer their correct question, but it's good to have it there. Postage and credit card machines are also other kind of machines that might be analog devices that need to be checked. And it's also important to check them because if you don't do it correctly, the store might not be able to open tomorrow. You need to check what's in there. And one of the things is that we need to check how to verify. So alarm system, credit card machine, how do we know that they really work? So 5 o'clock in the morning, on a Monday morning, just before the business opens, it's important to see that, like, I had an issue with a French credit card machine. I did not have a clue or not if I was working because it was just French coming out on display and on the receipt. So not sure. I bought things for €1 a couple of times just to see. But it seems to work. It worked. So migration approach. When we have done all the planning, we're going into migration. Are we doing it as a big bang or side by side? Big bang, everybody at once. Probably quite interesting for smaller sites. Larger sites might be, we might have to do it in several steps. But how do we do this? Depending on our plan, how we're going to do this, we have a couple of different options. So one might be that we have some local equipment that we need to connect to. If that's an IP-based PBX, we might come off easy just by setting up some kind of SIP trunk between those two machines. If it's not an IP machine, we might have to put a gateway or something in between, or the SPA has gateway components to work against this one. Anyway, the good thing with this one is that we can take extension for extension. If we have 100 users, you can be pretty sure that you're not allowed to move 0 to 10 on the first day and 11 to 20 the next day. You probably need to take things based on where using your settings. And that's much easier if you have some kind of equipment. On the same time, it's more complex. You might end up with having to buy new licenses for SIP in the other solutions and things like that. So this approach with two devices in parallel can be a bit harder to maintain as well. And eventually there comes a day where you need to do that big switch anyway. So you might need to go back there or someone needs to change it afterwards. But this is quite common that we end up in, of course. Another thing is if we're going central, then we probably have a PSTN connection coming in at the old site, and then we go into that central connection. Then it's a porting thing. We need to port, and that's also a question. Are we able to port individual numbers when doing this? Can we move certain numbers from one carrier to another or from one service to another? That's a discussion that we need to have with the carrier. In many cases, we're not able to do that. If we have to move everybody at once, then there's a big bang thing in here. And porting is always quite complex. And how many of you have been involved in porting numbers between carriers and between services? And your experience is that it works perfectly on the first attempt, right? I've never seen that. And everybody that says something else works at the carrier. But it's also quite complex. So if the carriers say that we are just able to port 100 numbers at the same time, often ends up porting 51 numbers. So it definitely works porting less numbers than the whole series. But it's what I mean here is important to verify that things really work and verify that you have a plan, that you might not do it during lunch on a Monday when it's the busiest period of the week, because things are probably not happening just in 1 minute in most cases. We had a very good porting a couple of months ago where everything went perfectly on the at the same. Every number was ported at the same time. It worked perfect. The problem is that it started 1 hour early, but everything worked very well. The other thing might be to have a new connection. If you're having, for example, a SIP trunk going, or a PRI going into the old solution, we're going to a SIP trunk. We might have a new PSTN connection delivered to the branch. There's also a porting thing. It might be easier to port things when it's with the same carrier, but still needs to move numbers. If you're going for the same numbers, in some projects we actually ended up giving new numbers to the users as well, which is absolutely an option. And I'm not sure about how it works in all regions, but in many countries today, we're going from regional numbers and local area codes and having more of a national dial plan. And many companies tend to go and change from that, so having a national dial plan instead. So it could be a perfect opportunity to do this. Or in a smaller branch, or if we're doing a real big bang, sometimes it could be just moving the cable from the old PBX to the new SPA. That's a real big bang. One of the good things with this one, it's really easy to switch back. It's as easy to switch back as to migrate. and that's good, because then you can, maybe a couple of days before, during an evening, we can just move the cable over, do all the tests, and everything works fine, or go back and fix everything. So that could be very compelling as well. So that might be an option. So before I close up here, just a couple of things that I think could make the difference. Some kind of hard factors first. Test your network. I doubt that anybody during this conference missed that there's a huge focus on call quality and on networking, right? And what we experienced in many of our projects so far is that when you're moving to Lync, there's, of course, a bigger dependency on the network. Nobody, if you're doing enterprise voice, branch appliances, everything, conferences still use the WAN. And we are very depending on the network. So check your network, because if that doesn't work, it can take a long time to upgrade and fix things, implement quality of service, or whatever you're doing. And the users are not happy with bad audio quality. And it's so much easier, harder to get back their belief in your new solution than to ruin it. So just make sure that you test your network properly before doing this. Do not underestimate traffic prioritization. I know there's been so much discussions with people working with Lync that you're not, you don't have to use QoS because we have an adapter codec and everything like that. I've probably heard it. And in some scenarios it might work. Lync might actually work better on a dirty network than other solutions. But if you're in a situation where there's no possibility to upgrade, you don't have the possibility to buy more bandwidth or anything, prioritizing traffic is what we have today. It might not be the perfect thing. I love everything I hear about SDN, and I hope this will solve all our problems in the world. wars and everything. But SDN is a very good start, but traditional quality of service is what we have today. So another thing is to have a very good test protocol. During the days before a big migration, we do changes in the last minute. And what's important to see is that when we do a very late change, test to see if you don't break anything else. If it's 4 o'clock in the morning and people are coming into business at 7, and everything is supposed to work there, it's quite easy to miss out the test because you're so tired. So have a small test protocols with smaller things just to make sure that you are good to go. You might not end up with a huge one taking hours to complete, but it's still some basic tests to make sure that you put most part in it. Build your own toolbox. I told you about the gateway. I have a gateway in my bag. I also try to always bring an analog phone, actually, just to test these things. Local SIM cards could be very good as well, because if you're in a country testing simultaneous ringing and things like that, how does numbers turn up on the display when you're calling someone else? Make sure that they are coming up in a regional format and not with double zeros or something in the beginning. It's important to be able to test from a local source. And sometimes numbers are not displayed correctly when going internationally. It might work perfect within the country, and you're sitting there troubleshooting things with your Swedish cell phone. And so local SIM cards is very helpful. And whatever you think is good in there. Bottle of Coke is always on my desk as well. Some other factors that might not be as technical. Don't trust the site administrator to be 100% correct. In many cases, a guy working with local IT in the branch might not have the perfect view of how everything works when it comes to telephony, and sometimes they're very sure about everything, but it turns out to be wrong. There are very good guys, but sometimes you might actually end up in situations where the site admin is not even your friend, and we had that situations as well. So make sure to gather information from more people. Ask other people as well, and don't just the site administrator. And ask the people working in the audit department, people working in the support organization, maybe how they work with telephony and what's important for them. It's not sure that might not always be that what they have today is perfect for them. It might be a perfect situation, perfect time to give them something much better. And ask every question 5 times. If you see that the answers varies, then nobody knows how it really is. So ask again and to really dig in. Because if you cheat here, it doesn't help if you say that he said. It doesn't help very much, because you still need to change it, fix it, and it might ruin your travel plans, or it might ruin your next week's projects, or it might just hurt people. So I would also say that end-user training is extremely important when changing from something that's so different from a traditional desktop phone, for example, going to Lync. And I don't think that everybody needs instruction on where to click. In some cases, it's just give them a good understanding of how this works and how to work differently, and people will be really happy. But we've seen very confused people in the morning when you just throw things out. And it could be a bit hard sometimes if you are doing a site deployment in a country where you don't speak the language and you rely on local people doing the training and things like that. But make sure that they get information in advance. And another thing that I always also try to do, if possible, it's absolutely not possible in all the cases, I say that I want to feel the heat. I want to be on site, if possible, at least in the larger sites and the more important things. I want to be there when we are doing the migration, so I can speak with the users, I can see the problem for myself, because it's so hard to sit on the other side of the world behind your computer with a headset and try to get an understanding of what doesn't work. And especially when you run into these things like the fax don't work and things like that, how do you test that? If you're not able to do it yourself. Sometimes you really need to run to that fax or check the cabling and everything like that. So feel the heat, be there. It's very much appreciated by the people at the branches as well. And if there's a calm day, everything goes perfect. I mean, we are remote workers, most of us, so you can just do the next project or sit there work with something else. And sometimes it's actually a nice country as well, and you can sit out in the sun and work. So. And don't leave them by themselves. When the projects are finalized, do not just skip. Go check back with them. Have like a monthly meeting or something and just see how things are working, because we've seen in several cases where communication hasn't been good, that people are getting dissatisfied with something, and they don't tell you necessarily. We don't see any reports, we don't see any cases coming in, but they are unhappy, and after a while they are really unhappy, and there's a crisis, you need to change something, and in the worst case, roll back, whatever it could be. So make sure that you always check back in some easy way just to see how they're doing, and if you do that and then take care of things quick, I'm pretty sure that people will love the new solution in most cases. So with that, I would like to say thanks a lot for coming here on the last session of the conference, and I hope I gave you some good advices and you get a good understanding of how this works. I'm Martin Lidholm at uclarity.com, or my Twitter handle is @mlidholm. I'll be here for a while afterwards answering questions. I'll go down, eat lunch, and just ping me if there's anything. This is my SIP address as well. So thanks a lot, and please fill out the evaluations. It's extremely important for all of us. So have a great journey home, and thanks a lot for coming here.